Hello and welcome to AI for Developers. I'm AI Educator Talking Bot. Today's lesson is titled Why I Rewrote My Trading Engine in Rust. Latency, safety and concurrency. Traditional languages like Python, while excellent for prototyping, often fall short in high-frequency trading. HFT environments. Latency becomes a critical bottleneck when competing for basis points. Garbage collection pauses, unpredictable execution times, and lack of true concurrency hinder performance. Addressing these limitations requires a more performant and predictable solution. Rust's zero-cost abstractions and ownership model allow for extremely performant code with minimal overhead. We observed a significant decrease in execution time for critical path operations after rewriting. Our trading engine in Rust stack allocation preference encouraged by the borrow checker minimizes heap allocations and garbage collection, as highlighted in real-world engine builds. Memory safety is paramount in financial systems. Rust's borrow checker eliminates common errors like dangling pointers, data races, and buffer overflows at compile time. This translates to fewer crashes, reduced debugging time, and increased system stability, which is vital when managing substantial capital at risk. Rust's built-in concurrency primitives, along with its fearless concurrency guarantees, enable us to easily exploit multi-core architectures. We parallelized order book processing, risk calculations, and market data ingestion pipelines, leading to a substantial increase in overall throughput. Message passing is strongly encouraged for inter-thread communication, a design pattern often used in high-performance trading systems. We implemented a customized agentic loop in Rust to manage trading strategies dynamically. This loop handles tasks such as market data analysis, order execution, risk management, and position monitoring. The speed and reliability of Rust are crucial for the responsiveness and adaptability of this AI-driven system. We leverage a private retrieval augmented generation (RAG) system, also written in Rust, to continuously optimize trading strategies. This system uses historical market data, news feeds, and economic indicators to generate insights and refine trading parameters. Rust's performance is key for processing the massive datasets required for effective RAG. To scale our Rust-based trading engine, we utilize a distributed architecture with multiple nodes processing market data and executing trades. Kubernetes is used for orchestration, and Prometheus and Grafana for monitoring. The low resource footprint of Rust allows us to run more instances on the same hardware, reducing infrastructure costs. The transition to Rust has resulted in a demonstrably improved Sharp ratio and a significantly lower risk of ruin. We are now exploring further optimizations, including custom memory allocators and lock-free data structures. The future involves integrating more sophisticated AI models for improved prediction and risk management. Continuous benchmarking and performance analysis are crucial for maintaining a competitive edge in the dynamic DeFi landscape. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.